Today's Daily Dose of Math is about the exponential function. Specifically, if you're given the rule for an exponential function, how to make a table of values and graph it. Now the basic form of the exponential function is y equals a times b to the x. And remember, you have to apply the rule of bedmass here. The b has to be brought to the exponent x first before being multiplied by the a. So I've made as simple an example as I can, y equals 2 times 3 to the x, and I'm going to start with that. Why do I use 2 and 3? I'm avoiding negative numbers, decimals, and fractions in order to avoid having the equation look complicated, because this is for people who are just starting. And I'm also avoiding 0 and 1, because 0 and 1, when you plug them into mathematical situations, tend to do different things than most of the values will do. And I don't want to make both a and b equal to 2, for instance, because then there's too many 2's, and it's harder to see what's happening because a is equal to 2, what's happening because b is equal to 2. No, I make them something different. So y equals 2 times 3 to the x, and I'm going to fill in this table of values, starting with x equals 0. Y therefore is equal to 2 times 3 to the 0, but anything to the 0 is equal to 1. So that's equal to 2 times 1, which is 2, and we have our first point. When x is equal to 1, y is equal to 2 times 3 to the 1, but anything to the 1 is equal to itself, so therefore 3 to the 1 is equal to 3. I have 2 times 3, and I have 6. When x is equal to 2, y equals 2 times 3 squared, which is 2 times 9, which is 18. And when x is equal to 3, y equals 2 times 3 cubed, which is 2 times 27, which is 54. Now I'm going to graph this. 0, 2 goes about here. 1, 6 will go about here. And 2, 18 will go about here. And we can see we need at least 3 points to see the shape of our curve. If we only have 2 points, you can draw a straight line through those 2 points, but this is not a straight line. And we have a curve that looks like this. Forgive the crooked drawing. Now notice how I scaled my axes. If I had scaled both axes the same, it would have been much more difficult to show this shape and to make the points fit on the graph. So I choose to scale the y-axis by 10s and the x-axis by 1s in order to see the shape of my curve a little better. Let's do this again with this other example, which is very similar, but this time, instead of a equal to 2, b equal to 3, I did the reverse. A is equal to 3, b is equal to 2. If x is 0, y is equal to 3 times 2 to the 0, which is 3 times 1, which is 3. And I can see I have a different y-intercept than I did over here. If x is 1, y is equal to 3 times 2 to the 1, which is 3 times 2, which is 6. Well, that's kind of interesting that we got the 0.16 in both of these. If x is 2, y is equal to 3 times 2 squared, which is 3 times 4, which is 12. And if x is 3, y is equal to 3 times 2 to the 3. 2 to the 3 is 8. So it's equal to 3 times 8, which is 24. Now I graph it. I've scaled my graph similarly, but not exactly the same. So when you compare the shapes of the two curves, you can't trust this graph completely. The x-axis is scaled the same way, but the y-axis is not. But you can trust your points. 0, 3 is about here. 1, 6 will be about here. And 2, 12 will be about here. And I have a similar looking curve, but it doesn't climb as rapidly as the first one. And that is because of the relative positions of the larger number and the smaller number in the a and b positions. Of course, I didn't put the 0.354 on this graph or the 0.324 on that graph because they didn't fit easily. But you can see now that we have a process that we can trust. When we have an exponential function, we just have to plug values from the x into the function and be careful, remembering to respect the rule of BEDMAS, simplify, and we're able to graph this. That is today's Daily Dose of Math. Please like and subscribe and share.